We've all dreamt of it, right? A future with flying cars zipping between skyscrapers. It's a vision that always feels like it's just around the corner. But what if I told you the real key to making it happen isn't some new super alloy or a crazy powerful computer, but something we literally throw away by the millions of tons every single day? Here's what most people don't realize about the future of our cities.
So the fancy name for this whole idea is urban air mobility. We're talking about a whole network of electric vertical takeoff and landing aircraft, or eVTOLs for short. Basically on-demand air taxis designed to just hop over the gridlock on the ground. And as you can see from these plans, this isn't just science fiction anymore. Companies are actively building and flying these things right now.
And we're not talking about some small niche industry here. Projections are showing that by 2050, this whole market could be worth an absolutely staggering $90 billion a year. That's not just big, that's a total game changer for how we think about getting around our cities. The potential is just massive.
But, and there's always a but, isn't there? There's a catch, a huge one. The very technology that makes these flying machines possible, their incredibly powerful electric batteries, is also their biggest weakness. And it's created this paradox that engineers have to solve before any of this can really get off the ground.
To really get what's going on, we have to pop the hood and look at the heart of these vehicles, the battery. And I want to be clear, this is not just a souped-up version of what you'd find in an electric car. The demands on an eVTOL battery are in a completely different universe.
Let me try to put this into perspective for you. There's a metric called the C rate, which is just a fancy way of saying how fast a battery is being drained. An electric car might just cruise along at about 0.1 C, but an eVTO, it needs up to 4.5 C just to lift off the ground. That kind of power draw creates something like 100 times more heat. It's not the difference between walking and sprinting, it's like sprinting a full marathon from the starting gun to the finish line.
And that stress just never lets up. For this to work as a business, these batteries have to be in the air constantly. This test here shows a battery going through 2,000 absolutely brutal cycles. That's a super fast 5-minute charge followed immediately by a full flight simulation. That's the kind of relentless pressure they have to withstand day after day. And all that power, all that heat, it leads to the one thing that keeps engineers up at night: thermal runaway. It's a technical name for a battery fire, but on a catastrophic scale. All it takes is one single cell to overheat, and it can set off a chain reaction, like a line of dominoes, igniting the entire battery pack. A single incident like this grounded the whole Boeing 787 Dreamliner fleet. Now imagine that happening, but hundreds of feet above a city. It's a failure that the industry absolutely cannot allow.
So this brings us to the big question. To contain that risk, you need to build a box around these batteries. And the material for that box needs a crazy set of skills. It has to be strong enough to contain an explosion, light enough so the aircraft can actually fly a decent distance, and, most importantly, it has to be flame retardant. So where on earth do you find a material that can do all of that? Well, the answer isn't in some high-tech lab.
And this is where things get really interesting. To find the solution, we have to leave the world of aerospace engineering completely and head over to one of the biggest and frankly weirdest waste streams on the entire planet. We're talking about a material that most people have never ever given a second thought. I want you to think about this. Every single year, the global poultry industry creates billions of kilograms of waste feathers. Most of it just gets thrown away, burned, or buried in landfills. It's a huge disposal problem. But hidden inside all of that biological waste is a material with a truly amazing molecular structure.
So what happens when you take these feather fibers and mix them into a modern composite material? Well, the results are kind of weird. You'd think it would just get stronger, right? But what happens is it actually gets a little less resistant to being pulled apart slowly. But its ability to take a sudden hard hit, that skyrockets. The material becomes way tougher.
And this is the magic right here. When you look at it under a microscope, you can see that the feather fibers create this tangled, chaotic web inside the material. So when a crack tries to form, it can't just zip straight through. It has to fight its way through this messy, interlocking network, which spreads out the energy and stops the crack in its tracks. It's what gives the material this incredible toughness.
Okay, so it's tough. That's awesome. But remember our number one problem? Fire. And it just so happens that feathers have another hidden superpower, one that evolution has been perfecting for millions of years. This quote from a research paper really cuts right to it.
See, feathers are made of a protein called keratin. It's the same stuff in your hair and fingernails. And because of what it's made of chemically, it's full of nitrogen and sulfur. Keratin is naturally flame retardant. When you hit it with intense heat, it doesn't just burst into flames. Instead, it chars and forms this amazing protective layer.
And right there, that's the moment. That's when the two totally separate parts of our story just click together. The massive safety problem for a $90 billion futuristic industry might actually be solved by a biological waste product we've been throwing in the trash for centuries. This detail changes everything.
So, what does this actually mean for the future of flight? Well, it means we're on the verge of a whole new class of materials, ones that combine our best engineering with the quiet, time-tested genius of the natural world. A battery box made from this keratin composite basically ticks every single box. It's lightweight, which means the aircraft has more range. It has that incredible impact strength, so it can contain a failure. It's sustainable. You're literally turning garbage into a high-tech solution. And, most critically, that natural flame retardancy could be the key to preventing a disaster and making sure passengers are safe.
And so the ultimate takeaway is this. The solution to one of tomorrow's biggest engineering challenges wasn't invented in a lab. It was rediscovered in nature's own design. It really makes you wonder, what other profound secrets are hidden all around us in plain sight, just waiting for us to see them in a new light?
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.